there is a point in space where survival stops being a matter of skill, engineering, or time, a point where no spacecraft, no astronaut, and no form of known life can continue. Not because of a failure in technology, but because the universe itself refuses to allow it. Beyond that point, space does not behave like a place anymore. It behaves like a limit. Most people think space is simply empty, a vast, silent void stretching endlessly in every direction. But that idea is misleading. Space is not passive. It has structure. It has rules. And those rules become increasingly violent the farther you go from familiar regions like Earth. At first, space seems survivable. With the right equipment, humans can stay in orbit. They can live aboard stations. They can even travel to the moon and beyond. But every step outward is not just a journey through distance. It is a journey through layers of physical law that slowly become more extreme, more unforgiving, and more absolute. And there's a final boundary where those laws do not just become harsh, they become final. In this video, the focus is not on distance in the usual sense. It is not about how many light years separate us from distant stars or galaxies. It is about something deeper, something more fundamental. The hidden limits of space itself, the points where survival is no longer difficult but impossible in principle. This is not science fiction. These limits come directly from real physics, from equations that describe how space, time, energy, and matter behave at the deepest level. Physicists like Brian Greene have spent their lives studying these laws, trying to understand what the universe allows and what it forbids. And what they have discovered is unsettling. There are regions of space where the normal rules of reality begin to break down, where time does not flow in the way we expect, where matter cannot hold its structure, where energy becomes so extreme that atoms themselves cannot survive, and beyond certain thresholds, even the concept of survival loses meaning completely. One of the most important ideas behind this is relativity. It tells us that space and time are not separate things. They are part of a single structure called spacetime. And this structure can bend, stretch, and twist under extreme conditions. That bending is not just mathematical. It changes how everything inside the universe behaves. Another layer comes from quantum mechanics. At the smallest scales, reality is not smooth or predictable. It is uncertain, probabilistic. Energy appears in fluctuations. Particles behave in ways that challenge everyday intuition. And when these quantum effects meet the extreme conditions of space, the rules become even more unstable. Together, these two theories define the boundaries of what is possible. And they do not just describe how space works. They also define where space stops being safe for anything that tries to move through it. Most people do not realize that space has limits in the same way that land or oceans have edges of survival. On Earth, humans cannot survive deep underwater without protection. They cannot survive at extreme altitudes without oxygen. Space works in a similar way, but the scale is far more extreme, and the consequences are far more absolute. The farther you move from Earth, the more layers of protection disappear. Atmosphere is gone. Magnetic shielding is gone. Thermal stability is gone. And eventually, even the familiar behavior, matter begins to change under radiation, gravity, and vacuum conditions. But there are points beyond even that, places where the rules themselves begin to shift. Not just conditions becoming harsh, but physics becoming fundamentally different. That is where this journey begins. We are going to move step by step from the edges of survivable space into regions where survival is not just unlikely, but physically impossible, where radiation, gravity, and the structure of space-time itself reach limits that no biological or mechanical system can overcome. By the end, the picture that emerges is not of a universe that is simply large and empty. It is a universe with boundaries, invisible, mathematical, and absolute. Boundaries that define where life can exist and where it cannot. And as we move forward, each layer will reveal something more disturbing than the last. Because in space, the most dangerous places are not always the ones that look extreme. They are the ones where reality itself starts to fail. Space looks calm from a distance, silent, still, almost peaceful. But that calm is deceptive. Because the moment a human body enters true space without protection, the process of survival begins to collapse instantly, not slowly, not gradually, instantly. The most immediate danger is the vacuum itself. There is no air, no pressure pushing inward on the body. On Earth, the atmosphere presses on every part of us all the time. It keeps liquids stable inside tissues. It keeps gases balanced. In space, that pressure disappears completely, and the human body is not designed for that kind of environment. Without oxygen, the brain begins to shut down within seconds. Within a very short time, consciousness fades. But even before that point, something more disturbing begins to happen at the physical level. The body is still intact, but the conditions holding it together are no longer present in the same way. Fluids inside the body respond to pressure changes. Blood, saliva, and other liquids begin to behave differently when external pressure drops to near zero. They do not explode, but they begin to destabilize. Gas bubbles can form inside tissues. The balance that keeps internal systems functioning starts to fail at a microscopic level. At the same time, heat becomes unpredictable. On Earth, heat moves through air or water in controlled ways. In space, there is no medium to carry heat normally. Instead, heat leaves the body through radiation. One side of an object exposed to sunlight can become extremely hot, while the shadow side remains freezing cold. This creates extreme thermal imbalance in very short periods. A human body drifting in open space could experience both extremes at once. One side exposed to solar radiation, the other facing deep cold. The result is not a stable temperature drop or rise. It is constant instability in how energy moves through matter. Another lesser-known fact is that space exposure does not cause immediate freezing, as often shown in popular descriptions. Instead, moisture on exposed surfaces begins to evaporate rapidly due to low pressure. This includes moisture in the eyes and mouth. The process is fast and unnatural, not violent in the way explosions are often described, but deeply destabilizing to biological systems. Even cellular structures begin to feel the absence of pressure. Cells rely on controlled environments to maintain shape and function. Remove that environment and biological processes begin to drift out of balance. It is not destruction in a single moment. It is collapse at the most basic level of structure. All of this happens without any physical collision. No impact, no explosion, no external force, just absence. Absence of air, absence of pressure, absence of the conditions that life depends on without even noticing them on Earth. Survival in this region of space is not a question of endurance. It is a question of whether protection exists at all. Without shielding, the body is not struggling against an enemy. It is simply exposed to a set of conditions that do not allow biological systems to remain stable in any form. And yet, this is only the beginning of how space removes the possibility of survival. Beyond Earth's atmosphere, space becomes far more dangerous in a way that cannot be seen or felt at first. There is no visible barrier warning of danger, no sound, no change in color, but something is constantly moving through space at extreme speed, passing through everything in its path, high energy radiation. On Earth, life is protected by a natural shield. The atmosphere absorbs and deflects a large portion of harmful radiation from the sun in deep space. The magnetic field also plays a major role, guiding charged particles away from the surface. Without this protection, life is exposed directly to forces that are normally filtered out before they can cause harm. In deep space, that protection disappears completely. There is no atmosphere to slow particles down, no magnetic field strong enough to redirect them, The result is a constant stream of radiation passing through spacecraft, objects, and biological tissue without resistance. This radiation comes from multiple sources. The sun releases powerful solar flares and coronal mass ejections that send bursts of high-energy particles across the solar system. Beyond the sun, distant stars and supernova explosions send even more powerful cosmic rays. These particles travel for millions of years before reaching any object in space. When they pass through living cells, they do not behave like ordinary physical matter. They do not gently interact. They strike at the level of atoms. They can break chemical bonds and damage DNA directly. This damage is not always immediate in its effect, but it builds up over time in ways that are difficult to reverse. One lesser known fact is that cosmic radiation can pass through most materials. Even metals and spacecraft walls only reduce part of its intensity. They do not fully stop it. This means that long-duration exposure in deep space gradually increases risk, even inside protected environments. The human body has some ability to repair DNA damage. On Earth, this repair system works effectively because radiation exposure is relatively low. In deep space, however, the rate of damage can exceed the body's ability to repair itself. Cells begin to malfunction, mutations accumulate, biological systems slowly lose stability. At high levels, radiation does not just cause long-term health risks. It can become immediately dangerous. Strong solar events can deliver doses large enough to affect astronauts within hours or days if they are not shielded properly. This creates a condition where survival is no longer measured in years or months, but in very limited time windows. Another important detail is that radiation in space is not constant in intensity. It can spike suddenly without warning. A calm environment can turn into a high radiation zone in a short period of time due to solar activity or passing cosmic events. This creates a hidden layer of instability in space. Even when everything appears quiet, the environment is still active at a level that continuously challenges biological survival. It is not a single threat that can be avoided. It is a constant presence that cannot be turned off or escaped by distance alone. And deeper into space, this invisible force becomes even more dominant, shaping the boundaries of where survival can continue at all. Radiation in space is not something that announces itself. It does not glow in a visible way. It does not make sound. It does not warn before it arrives. It simply passes through everything constantly without stopping. Outside Earth's atmosphere, there is no natural shield left. On Earth, the air above us absorbs a large portion of harmful radiation. The magnetic field bends charged particles away from the surface. This combination keeps life in a stable range. But once you leave that protection, the situation changes completely. High energy particles begin to flow in from all directions. Some come from the sun. These solar particles are released during powerful eruptions that can send massive bursts of energy across space. Others come from far deeper regions of the universe. Distant stars, exploding supernova, and unknown cosmic events send particles that have traveled for millions or even billions of years before reaching anything in their path. These particles are not gentle. They move at extreme speeds. When they pass through matter, they do not simply bounce off or slow down. They interact at the smallest levels of structure. ATMs are affected. Chemical bonds are broken. The damage begins at the level where life itself is built. Inside a living body, every cell depends on stable DNA to function correctly. Radiation disrupts that stability. It creates breaks in the genetic code. Some of these breaks can be repaired, but not all. Over time, repeated exposure builds up damage faster than the body can recover. One lesser known fact is that cosmic radiation is not uniform. It arrives in different forms and energies. Some particles are relatively low energy and pass through with minimal interaction. Others are extremely powerful and can penetrate deep into matter, even through thick metal shielding. This makes long-term protection in space a complex challenge. In deep space, radiation levels are not just higher than on Earth. They are fundamentally different in behavior. There is no predictable pattern that guarantees safety. A region that seems calm can suddenly be affected by a burst of solar activity. In those moments, radiation levels can increase dramatically in a short period of time. For humans, this creates a hidden danger. There is no direct sensation when exposure begins. No pain signal. No immediate warning. The effects accumulate silently inside the body. Cells begin to malfunction. Systems that depend on precise biological balance start to lose consistency. At higher doses, the damage becomes faster. Astronauts in deep space without proper shielding could reach dangerous exposure levels within hours or days during strong solar events. This is not a slow environmental hazard. It is a time-limited condition where survival depends entirely on protection systems working perfectly at all times. Even advanced technology has limits. Spacecraft can reduce exposure, but they cannot fully eliminate it. Shielding adds weight, and there is only so much material that can be carried. This forces a constant balance between protection and practicality. No system can create complete immunity from cosmic radiation. This means that deep space is not a stable environment for life. It is a place where exposure is continuous, unavoidable, and cumulative. Every moment outside Earth's protective layers adds another layer of risk. And as distance increases further into space, this invisible force becomes even more dominant, shaping how long anything can remain alive before the environment itself becomes too extreme to endure. There is another boundary in space that is not made of distance or material. It is made of speed itself, a limit built into the structure of the universe. It is known through relativity, and it defines something no object with mass can ever cross. Nothing with mass can reach or exceed the speed of light, not because of technology, not because of engineering limits, but because of how space-time behaves at its most fundamental level. The universe does not allow it. At low speeds, motion behaves normally. Energy increases linearly. Acceleration feels predictable. But as speed increases and begins to approach the speed of light, something strange starts to happen. The rules begin to change in ways that are not intuitive. The closer an object gets to the speed of light, the more energy it requires to continue. Accelerating, this is not a small increase. It grows dramatically. At extreme levels, the energy required becomes effectively infinite. No engine, no force, and no system can supply that amount of energy. This creates a natural wall in motion, not a physical barrier, a mathematical one, a point where forward progress becomes impossible no matter how much power is applied. But the effects do not stop at energy. Time itself begins to behave differently. This is known as time dilation. As speed increases, time slows down for the moving object compared to the outside universe. Clocks tick more slowly, processes take longer. From an external perspective, the traveler appears to move in slow motion. At speeds close to light, this effect becomes extreme. Time for the traveler can stretch in ways that feel disconnected from the rest of the universe. Meanwhile, outside observers continue at normal flow. Two different realities begin to form, both correct, both real, but no longer aligned. One lesser-known detail is that this effect is not just about perception. It affects physical processes inside the object itself. Atomic reactions, biological functions, and even internal energy exchanges are influenced by this time distortion. As speed increases further, another layer appears. Matter itself begins to behave differently under extreme relativistic conditions. Atoms are held together by electromagnetic forces. These forces respond to energy and motion. At extreme velocities, the structure of matter becomes increasingly unstable. Particles inside atoms experience conditions that push them away from their normal configuration. The stability of matter is no longer guaranteed in the same way it is at lower speeds. The very structure that defines physical objects begins to face limits. There is also a directional distortion. At near light speed, space in front of the object appears compressed. Distances shrink in the direction of travel. Behind it, space stretches. This is not an optical illusion. It is a real consequence of how space-time transforms under extreme velocity. Together, these effects form a barrier that is not visible but absolute. Energy becomes infinite. Time separates. Matter destabilizes. Space itself reshapes around motion in ways that prevent further acceleration. This is not a wall in space. It is a wall in possibility. A point where motion stops being something that can be increased. And even beyond this limit, space continues to introduce even more extreme conditions where motion and existence itself are tested in completely different ways. There is a place in space where all known rules of survival collapse at once. It is not far in the normal sense of distance. It is defined by gravity so extreme that even light cannot escape. This is the region around a black hole. Black holes are among the most powerful objects in the universe. They are formed when massive stars collapse under their own gravity. What remains is not a solid object, but a region where gravity has become so strong that space-time itself is pulled inward. At the center of this system lies the event horizon. This is not a physical surface. There is nothing solid to touch. Instead, it is a boundary in space-time, a point of no return. Once anything crosses it, escape is no longer possible. Not even light can move back outward. The reason is not that light slows down. It is that space-time is being dragged inward faster than anything can move outward. The fabric of space itself is falling into the black hole. Every possible path leads deeper inside. No direction leads out. As an object approaches this boundary, strange effects begin to appear. Gravity does not act evenly. The force on one side of an object becomes stronger than on the other side. This difference creates extreme stretching and compression. Scientists describe this as tidal forces. For large objects like spacecraft or even planets, these forces can become violent. One part is pulled much harder than another. The object is stretched lengthwise and compressed sideways. This process is often described in simple terms, but the reality is far more complex and far more destructive at the structural level. One lesser-known fact is that the severity of these tidal forces depends on the size of the black hole. Smaller black holes create more intense stretching near the event horizon. Larger black holes can allow an object to cross the boundary without immediate physical disruption, but the outcome still leads to the same end deeper inside. Time also behaves differently near this region. From the perspective of a distant observer, an object approaching the event horizon appears to slow down. It seems to freeze at the edge, but from the perspective of the object itself, time continues normally until the crossing happens. After crossing the event horizon, no signal can escape outward. No information returns. The boundary marks a one-way transition into a region, disconnected from the rest of the universe. Inside, space-time continues to curve inward. All possible paths lead toward the center. The direction of future movement becomes the direction of deeper collapse. This is not just strong gravity. It is a complete restructuring of what direction and motion mean. At this stage, survival is no longer a question of resistance or endurance. It is no longer about protection or adaptation. The rules that define physical existence no longer provide a framework where survival can be described in any meaningful way, and yet even this extreme region is not the final limit imposed by the universe, because space itself continues beyond these boundaries in ways that remove access entirely, even without entering anything like a black hole. There is a limit in space that does not come from gravity, radiation, or speed. It comes from the universe itself growing larger, not just in size, but in the way space stretches across time. The universe is expanding. Every distant galaxy is moving away from every other galaxy. This is not because galaxies are flying through space in a traditional sense. It is because space itself is stretching between them. At small scales, this effect is invisible. Inside galaxies, gravity holds everything together. Stars, planets, and solar systems remain stable. But across vast cosmic distances, expansion becomes dominant. The farther away something is, the faster it appears to move away from us. At extreme distances, this expansion creates a surprising effect. Some regions of space are moving away faster than the speed of light relative to us. This does not violate relativity because it is not motion through space. It is space itself expanding between 2 points. This leads to a boundary known as the cosmic horizon. It is not a physical wall. It is not a structure that can be touched or crossed. It is a limit of access. Beyond this horizon, there are regions of the universe that can never send information, light or matter to us. One lesser known detail is that this horizon is constantly changing. As the universe expands, more regions cross this boundary. Over time, more galaxies move beyond what can ever be observed or reached. Even if a spacecraft traveled at the speed of light, it would not be able to overcome this expansion in certain regions. The space between the traveler and distant galaxies would still stretch faster than the spacecraft could move. The destination would always recede, faster than it could be approached. This creates a strange structure in the universe. There are places that exist but are fundamentally disconnected, not because they are destroyed or hidden, but because the expansion of space prevents any interaction ever occurring. Another important fact is that light from these regions can still be visible for a limited time. But once they cross the cosmic horizon, even their light can no longer reach us. The information becomes permanently lost to future observation. This means that the observable universe is not the entire universe. It is only the part that remains connected through the structure of expanding space. Everything beyond it exists in a separate causal region, isolated by cosmic expansion. This limit is not caused by force or energy. It is built into the geometry of space-time itself. Even with unlimited technology, no object can bypass it because it is not a barrier to overcome. It is a boundary defined by how the universe grows. As expansion continues, this horizon slowly reshapes what parts of reality are accessible. It redraws the map of existence not by movement through space, but by the stretching of space itself. And beyond even the structural limit, there are still scales of reality where space and time begin to lose their normal definition entirely, revealing another layer where physics itself becomes uncertain. At the deepest level of reality, there is another boundary. It is not found in deep space or near black holes. It exists at the smallest possible scale the universe allows. A scale so small that space and time themselves begin to lose their familiar meaning. This is the quantum breakdown zone, often linked to the Planck scale. At this level, the ideas of smooth space and continuous time begin to fail. The laws that describe planets, stars, and even atoms stop working in the way they normally do. In everyday life, space feels continuous. You can move smoothly from one point to another. Time flows in a steady direction, but at extreme microscopic scales, physics suggests the smoothness may not hold. Space may not be continuous at all. It may behave more like discrete units, where distances and intervals cannot be divided endlessly. This is not directly observable with current technology. The scales involved are far beyond anything we can measure today. But the equations of modern physics hint at a limit where the usual structure of space-time stops behaving normally. At this level, quantum effects become dominant. Particles do not behave like solid objects with clear positions and paths. Instead, they exist in probabilities. Their behavior is described by uncertainty, not certainty. This is already true at atomic scales, but at the Planck scale, this uncertainty may extend to space itself. One lesser known idea is that space-time itself could fluctuate. Instead of being a fixed background, it may behave like a constantly changing structure. Geometry could shift randomly at extremely small scales, making the concept of a stable location less meaningful. This leads to a situation where the very fabric of reality becomes unpredictable. Not just particles, but the stage they exist on may lose stability. Distances may not remain fixed. Time intervals may not remain consistent. The usual rules that define cause and effect begin to blur. Current physics cannot fully describe what happens beyond this point. The equations of quantum mechanics and general relativity both work extremely well in their own domains, but they do not fully agree at this extreme level. When combined, they break down in ways that suggest missing pieces in our understanding. This is why physicists search for a deeper theory that unifies these descriptions. Without it, the Planck scale remains a boundary where predictions stop being reliable. It is not just a technical limitation. It is a sign that our current view of reality is incomplete. At this scale, even the concept of distance becomes uncertain. 2 points that appear separate in one moment could lose that distinction in another. Space itself may not have a fixed structure. It may be constantly shifting in ways that are not yet fully understood. Time may also lose its familiar direction. Instead of flowing smoothly forward, it may become irregular, with no clear distinction between past and future at the smallest levels. This challenges the very idea of a continuous timeline. All of this suggests a hidden layer beneath the universe we observe. A layer where the rules that define existence are no longer stable enough to form a consistent picture. And as physics continues to probe deeper into these limits, it approaches questions that may redefine what reality itself actually is. Across everything explored, one idea becomes impossible to ignore. Space is not a simple empty stage where anything can go anywhere. It is a system built with limits, hard limits. Some are visible in their effects. Others exist only in equations, but all of them define what can survive and what cannot. At the smallest level, vacuum removes the conditions needed for life. At higher exposure, radiation silently breaks down biology at the level of DNA. As speed increases, relativity turns motion, time, and matter into something unstable. Near black holes, gravity reshapes space-time so strongly that escape is no longer part of reality. Across cosmic distances, expansion of the universe creates regions that can never be reached, no matter how long travel continues. And at the smallest scales, quantum physics suggests that space and time themselves may stop behaving in any predictable way. Each layer adds a new boundary. Each boundary removes another possibility. Not because technology is weak, but because the structure of the universe does not allow it. This is the deeper truth behind all of it. Survival in space is not only about distance or endurance. It is about crossing into regions where the rules of reality begin to change. And at certain points, those rules do not just become difficult. They stop supporting life in any form. Even with advanced understanding, even with technology far beyond what exists today, these limits do not disappear. They are not obstacles that can simply be engineered around. They are part of the foundation of physics itself. The universe is far larger than what can ever be reached, and it is not fully open. There are boundaries written into space-time, into energy, into motion, and into the smallest structure of matter. Some regions of space are not just distant, they are fundamentally inaccessible. And this leads to a final unsettling idea. There are places in the universe where the laws of physics do not just make survival difficult. They remove the possibility entirely, not by force, not by destruction, but by definition. That is where the known picture of reality begins to end, and something far less understood begins to take its place. If this journey through the limits of space spark curiosity, consider liking the video and subscribing. There is still much more about the universe that remains hidden, and every new discovery brings us closer to understanding just how deep those limits truly go.